Okay, sorry, I ran out of battery. So this is the problem. The problem is to find. Sorry, one. Problem is, sorry, page 2, page 3. This is the problem. The problem is
Hola.
that you have two
Hola, mi reina.
charge, and when you see the electrical field on the x-axis, at this point you will see this vector and you will see this vector. When you go farther through, on this point you will see a small vector with another orientation like this, very small, and this vector. So if you are here, maybe you see a big vector. You see this. You see, I don't want to spoil this. You see this vector, and you see the other one. Okay, I don't want to spoil the picture. Let me erase something. Let me erase this. Okay. Okay. So the electrical field on the x-axis is going to change. So is going to change in the value, and what we are looking is the total electrical field. So it's a sum. It's this one. Let me put it again. It is this the one that is produced by the chart that is here, chart number 2, and the one that is produced by chart number 1 that is here. So this is the amount, the electrical field X, the total electrical field. So the electrical field due to 1 is KQ divided by the distance square. The distance square is clear, that is, if I am at the position that is a distance X from the origin, the distance square that separates the charge from the point is Pythagoras theorem, is ax squared plus I squared. The vector E1 have a unit vector U sub R1, that is this one, U sub R1, okay? And R1 is this vector. With E2 happened the same thing. The vector, the electrical field produced for the charge 2 on the point X is K by the charge Q divided by the distance square is the same distance. This distance is the same distance than this one. So the magnitude of R1 is equal to the magnitude of R2 for all points on the x-axis. So this is the electrical field on the point X. This is the magnitude, and this is the unitary vector that is different than this unitary vector, because this unitary vector is this one, U sub R2. So we can do it in two ways. The first way is the standard way that I have asked you to do, is to find R1, that is this one. R1 is this vector, R1 is this vector. Look at this vector here. Here, look at R1. R1 is the composition of two vectors, the vector that is x time in the y direction, and the vector that is a time on the j direction. So if you look for R1, R2 is this vector. So now you should find U_R1 as R1 divided by the magnitude of R1, and you could work in the classical way. I'm going to use another way to use it, another method. Please do this way, meaning that you take U sub R1 will be R1 x minus x divided by square root of ax squared plus x squared minus a times a square root in the y direction and j direction, etc. Well, I'm going to use another method that is also even easier. You see this angle theta is the same angle that this theta. The electrical field produced by charge 1 is this one. So if this angle is the same one that this angle, when I see the total vector, I see that the y component of each vector produced for each charge cancel. So only survive the x components. The x component of both survive, so it will be a double of one of them, the x component of the total electrical charge. So the total electrical charge is, of course, E1 plus E2, but I'm going to sum knowing that E1 plus E2. So the magnitude of Ex is E1x plus E2x, the components x. So what is the components of x of E1? Well, you project on the x-axis is magnitude of E1. So this is E1, this is theta. So the projection is simple magnitude of E1 by cosine of theta. So magnitude of E1 by cosine of theta, and what is the magnitude of E2 on the x-axis? Well, due to the electrical field, E2 is the magnitude of E2 by cosine of theta. It also is projected through the x-axis. So this is the total magnitude of the electrical field on the x direction. Okay, and what is the magnitude of A1? Well, I see here the magnitude of A1 is here, is these things, is so will be. What is cosine of theta? Cosine of theta, if you see in the picture, cosine of theta is this side divided by the hypotenuse. So will be x divided by square root of x squared, a squared plus x squared. By the magnitude of E2 by cosine of theta will be this. E1 and E2 is the same, so this is our equation. 2 times E1 by x, and 2 times E1 is these factors, okay, multiplied by x, divided by the square root of a squared will be square root of a squared plus x squared multiply 1 over this divided by, you see that how it appeared, the 3.5. Okay, sorry for the interruptions, we go. So we have this electrical field, this one, this is the total magnitude of the electrical field, and of course the electrical field run, the total electrical field run in the I direction. So, and this is the magnitude is this one, 2kq, okay, and it's written, I suppose, in the next page, page 4, okay, and the next page where it say, well, this is the electrical field. What is the variation of the electrical field respect to x? Well, the variation of the respect to x, we have to make this derivative, and the derivative of this is the derivative of the first, that is 1, by the derivative of the second, plus the derivative of the second, which is minus 3.5, by the function minus 3.5 minus 1 minus 5.5 by the internal derivative of x squared, which is 2x, and by the other one x, that is this x, okay, is this x. So the derivative will be equal 0, so I can find the minimum. The minimum of the curve is when the slope go to 0. If the slope is 0, you are in a minimum. So I'm trying to look the slope of this function, of this electrical field, and I try to see the slope when the slope is 0. And when the slope is zero is when all this equation, all this, all this, all this, all this is zero, and this meaning is this, and the meaning of this is this, and the meaning of this is this, and the meaning of this is this. Okay, so problem is solved. You make the calculation by yourself. The other question that it's asking you is something that you have to know how to approximate. Ex is 2kq. I'm going to forget the 2kq. Okay, is x divided by x squared plus ax squared divided by 3.5. Okay, there is a constant here phi c that is 2kq. Okay, when x go to infinity, or x is very very big to a, so this electrical field is very similar to cx divided by x squared elevated to 3.5. In some way what we have done is, because a is very small, we have depreciated a against x, because x is very big. It's like saying I have $1 million in one side and I have $1 in another side. I'm saying that $1 million plus 1 is $1 million. Is the same thing. So I have depreciate a squared in front of x squared. So will be x squared divided, so will be cx divided by square x cubed, so will be approximated by 1 over x squared. So this is the approximation of the field when x go to infinity. When x go to 0, there is another approximation that you have to learn. Let's go to a new page. Let me see, x divided by x squared, correct, is correct, is correct. So I will go now. Let's go to make the two approximations. The two approximations are when x is bigger than a. When x is bigger than a, it means that we are looking very, very far. And an x that a is very, very small. So we are looking very, very far. So if we are looking very far, the a squared is very small compared to x squared. So we depreciate a squared. So for x bigger than a, the equation will be ax equal to kq divided by x squared 3.5. So x cubed. So will be 2kq divided by x squared. So in the limit that x is very big, the electrical field look like one big electrical field of charge 2q at a distance x. So it will look like all the charge is on the center with charge 2q, and you are looking very far. So the second question is the approximation when x is very near the origin, or when x is very, very small compared to a. If x is very, very small compared to a, we are here. So we do the same technique. The same technique is, if x is very small compared to a, means that a is very big compared to x. So it will be a squared elevated to 3.5, it will be a cubed. So in this limit, ex will be 2kq x divided by, I depreciate x compared to a squared, so I depreciate, so will be only a squared elevated to 3.5. So the electrical field will be 2kqx divided by aq. Well, this is the approximation. It's an electrical field that is proportional to x. So if it's proportional to x, this electrical field, no, nothing. If it's proportional to x, it's proportional to x. confirm.